Hi, folks. Since people are clearly still drifting in from after lunch, we'll give it another couple of minutes. But as Ellen just said, if you're not already signed in to the tool, please do that as soon as you can so that we get an accurate count for room sizes in the future and so that you're all ready to put your hands up if you need to make comments. Thanks.
What do you?
Okay, folks, if you could find your seats now, that'd be great. We're getting ready to get started. As the sign on the front says, this is the Media Over Quick working group for IETF 116. If you thought you were in a different working group, now would be an excellent time to rectify that. And a reminder that this session is being recorded. For those of you who just joined, please remember to either scan the QR code or log into the tool to make sure that your presence is recorded so we get accurate room sizes, and to make sure that you're able to raise your hand if there are questions or comments you wish to make at the mic later on in the session. This is the IETF Note Well. This is a reminder of the IETF policies on various topics such as patents and the Code of Conduct. I'm not going to go through it all, but you're invited to do so either by yourself or with counsel, depending on your feelings about how much lawyers need to look at the stuff you're agreeing to. We do appreciate your paying attention to it, though, because we will hold you both to the Code of Conduct and to the IETF patent policies. Meeting tips. If you're in person, please make sure to sign into the session as we've been discussing. Use Meet Echo to join the mic queue. We have had a few cases in the past part of the week where the network has gotten flaky for a couple of people. So if you have a problem with that and join the mic queue, just signal us, the chairs, that that was the issue, and we'll do what we can to make sure that you're heard. Please wear masks unless you're actively speaking at a microphone. If you're still finishing up lunch and have a bit of a beverage or something like that, you can also take them off briefly to have a sip of your drink or to have a bite of your lunch. But that's not an excuse to go without them. This is the policy of the IETF is to wear masks at this session. For our remote participants, we would like you to make sure that your audio and video are off unless you are presenting or asking a question during session. And we strongly suggest you use a headset or voice canceling or noise canceling microphone just to make sure that any extraneous noise isn't filtered into the room. And I feel like I should start over, but I'm not going to, because we need to make progress, and that's what we're here for. Our agenda today is listed here, and the notes are listed there. I'm Ted Hardy. This is Alan Frindell. We'll be watching the Zulip relay ourselves and relaying anything to the microphone. If you want us to relay something, simply put mic in front of it in the chat comments, and one of us will take that up. Note takers, Magnus is actually volunteered for tomorrow. Today we have Ali and Chuan Ma, thanks to both of them. And thanks to my co-chair, Alan, for bringing the chocolate all the way from Seattle to incent them, since we're now resorting to bribery. Agenda for day one, we are currently here, Administrivia. The next bit will be Suhas doing a presentation of the scenarios draft. You'll see a link to that there. There are also some slides. Those were unfortunately a bit late, so if you have not had a chance to look at those, or if you grabbed them a little bit earlier, you may want to grab a new copy because they were just updated. There's also a discussion of the transport protocol deltas between that and the existing drafts. Some discussion, then we'll go into discussion based on WRF Draft 04. And then Chuan Ma will make a presentation related to deadline-aware relay extensions. Tomorrow's agenda, yes, we have 2 meetings. We'll talk briefly about what an adoption call will look like. We're not planning on an adoption call here at 116. This would be for the first draft after 116 if there's consensus in the room and we agree on what that draft should look like. There'll be some architectural discussion, a catalog specification presented by Will Law, and a discussion about whether or not we need an additional interim. If so, what planning for that should look like. And presuming that we have time for that, Jordi Senzano-Ferret will present the open source proof of concept that he's put together. Looks like we have somebody in queue.
Colin, just one trivial one. I don't think it's possible for people to tag issues in the warp repo. So I tried and I couldn't, and I think even have commit privileges. So.
Okay, thanks for letting me know. I can do it, and so as the typical foolish thing of it worked for me, didn't realize it wasn't working for others. We'll take a squint at that and see what we can do. If you are having trouble with that and want to mark something as architectural, please drop a note to mock-chairs and we'll take care of it. Any other comments? Glenn Dean asks, is John Postel's middle name actually Bruce? Thank you for reading the note well, Glenn Dean. Yes, we actually put an Easter egg in the note well. John Postel's middle name was Bruce. Thanks for reading the note well. And with that, we will go off to Suhas. You're up.
Is it working now? Yeah, it's working. Hi, everyone. Why are we here? Just to give the context, we have really done good work on addressing requirements for ingest and streaming scenarios, so ingest and distribution for streaming scenarios, but we haven't spent good amount of time thinking about what is it, about two different areas that MOQ is chartered with. One is the real-time topologies and the requirements that brings, and another thing is relays, and how do we build the relays that would work for unified use cases that MOQ is chartered with. Next slide. So what's happening out there? This is not first time we have discussed this. There's quite a few active threads, pull requests, and issues. We've been discussing this for a while. This is a time we need to kind of come together and see how can we make the MOQ-based transport work for the use cases that it's been chartered with. Next slide. So I'll start with giving a typical scenario where you want to use a real-time scenario, which is slightly different from how streaming scenario would work. In this case, you can see there are multiple emitters, each having different tracks or different qualities, identified by the thickness of the line, and color of the line means different media types or different tracks. And they send all those things over one quick connection. And the main role of the relay is to look at those tracks and look at the what the receivers need, and basically tries to answer those queries in a highly scalable way. And it needs to be able to make those decisions on fly. And one of the different things about the receivers is that in interactive scenarios, receivers, they come and go, and they are on network legs that are they differ over the set of receivers, and they're never, some are congested, some are not congested, and they also come with different kinds of receivers who are capable of something, they're not capable of something. And this kind of dynamicity needs to be considered when we think about the supporting different use cases, and also how it maps to the data model and things within the protocol. Next slide. So just putting more words on the previous deck. So interactive scenarios are mainly unified in just on distribution system. That means whatever the identifiers we use on the data model that we use needs to be visible throughout the systems, depending upon how someone builds the system. And different multiple emitters, they can dynamically come and go. Their tracks can be added and removed. Say, for example, someone is doing audio video, they add the screen share, they remove the screen share. And one of the important things of building a relays that would support interactive scenarios is relays should be able to take tracks from multiple, what we call as bundle in the today's draft, split it up into individual tracks and merge them based on how the relays work. We would like to have this flexibility where relays need not have to be tied to a bundle restriction. They should be able to kind of create the prioritization domain they would like to, and also use the quick connection resources as efficiently as possible. And having that as a requirement would be a nice thing to consider. Next slide.
So as he's changing slides, let me remind you, so we have a good number of people here who are not native speakers of English. So if you can slow your pace a little bit down so it's easier for people to follow, that would be useful.
Thank you. Okay, this scenario 2 is we are showing a use case where there are two different distribution systems. Like you can think of, two different relay distribution systems, one in green and another one in gray. And we have two different applications, one colored yellow and another colored orange. And they're emitters, and they all try to send some tracks that might traverse across the distribution systems to the receivers who are interested in those tracks. And in this case, the receivers are all interested in the applications from tracks from both applications. And we need to make sure that in the example, the relay R3, which is in the gray distribution system, needs to understand what that red track means. Who does it belong to? Does it belong to E1 or E2? Or the E1 in the application 2. It's very important that we build the data model and identifier scheme that would work in this kind of system setups as well. Next slide, please. So what does it mean in terms of requirements? We need to have MOQ, must support media flows within and across distribution networks. It should have some way to there should be no ambiguity in identifying the tracks, and also the protocol behavior should be uniform. We cannot have protocol behavior in one way within the system, and it goes across the system to have different protocol behavior. We need to have a uniform protocol behavior across hops, and tracks must be independent and hence provides an access to subscribe to and publish to. And this should work regardless of having web transport or not, because there are many use cases where we would want to have this supported over native click session. And any of the relays, regardless of in the green or the gray, they should be able to make the decision about forwarding or dropping or caching independently and uniformly, depending on the object should carry the necessary information to make such decisions. Next slide. Scenario 3 is more on the authorization front, wherein the way it works today is that the catalog that's supposed to provide the tracks is not readable or parsable by relays. That's an expectation. And once you receive the catalog, and when you do subscribe and publish, it should carry the necessary authorization information so that relays can now act on or should at least validate the authorization so that they are willing to participate in publishes and subscribes. And we need to think about how we want to do that. Next slide. So requirements on the base transport would be emitters and receivers need permissions to publish or receive on the tracks. And the expectation, a high-level expectation is that the emitters would receive an out-of-band way some token that would describe what is authorized for a particular emitter or a receiver, and that needs to be provided to the relays. And relays are the policy enforcement points who would participate in, who decide who can participate in publishing or subscribing. And the main thing here is that we need to keep in mind that catalogs are opaque to relays. And when you do subscribe or publish, we need to have that information very clearly so that they're willing to serve the publishers or subscribes. So at this point, I will ask Christian to take over.
Yes, I mean, one of the specificity that we have in the scenarios is that for real-time communication, we also want to support large fan out. I mean, an example of scenarios that we have been considering a lot of time is the case of, say, an enterprise plenary meeting in which like several hundred people or several thousand people are following a real-time conference centered in some big conference room somewhere. And that scenario, that's one of the reasons we like the idea of having relays. It's one of the scenarios that relays make possible, because relays make possible a large fan out. But if you have a large fan out, we have a problem with adaptation. If you have a large fan out, you will have a source sending to hundreds or thousands of recipients in real time, and that source will probably not be able to adapt to every change in the receivers. I mean, the traditional way in the receivers is to ask for a different track. I mean, they say, hey, I was trying to get the high def track, and I think my link is too slow. I will go for the low def track now, please. That kind of stuff doesn't scale very well in these large groups because it creates a lot of traffic going to the source. It also creates delay in the middle of the connection. So we think that for those large fan-out scenarios, what we really want is some kind of layered encoding in which the relays can peel off the layers that are excessive in real time. And this support for layered encoding is, I think, a major requirement that should be very explicit. Now, next slide, please. The layered encoding, there are examples. I mean, the example in the graph is taken from the AV1 specification, showing different layers in which a given media can be seen at 15 frames per second, or 30 frames per second, or 60 frames per second, in low definition or in high definition. And that creates a complex graph of dependencies between the objects. I think that we have to bite the bullet and define a way to express that graph of dependency in a way that can be easily handled by relays. And what I have been proposing for a long time is to define that using two concepts. One, a sequential ordering of the objects within the group, which has a natural order. That's what the numbers in the figure here are, the F1, F2, F3, etc. This is the order in which the frames would be processed if there was no problem and everything could be sent without any delay. And then a priority level that says what can be dropped, but also can be expressed in terms of dependency, saying that a given object can only be useful if all the dependencies are present. And we define the dependencies are all the other objects whose sequence number is lower and whose priority is same or lower. In that case, if we start from 0. And we go from there to the transport requirement that we'll see in the next slide. But first, a point that I want to know, not quite yet, please. First, I want to see one point that we are seeing there is that the dependencies that when you do this projection of complex dependency until a single order, you cannot really map a 2D graph into a 1D graph without making choices. And for example, what I have at the bottom is what we will do if the choice was frame rate first. But if in that case, I will have 4 layers of priorities, one with the 15 frames per second, the second one with the 30, the third one with the 60, and then a fourth layer with all the higher definition. The reason all the higher definition are packed together is that it doesn't make sense if you do higher definition to only do high definition at 15 frames per second, while doing transmission at 60 frames per second, transmission at 60 frames per second at lower definition. So if we do that, we do a projection, that's a choice. We could do a different choice, which is to say we want to have a spatial definition first, and so we say, hey, try to do 25 at high definition first, and then try to do 30 high definition. That will give us a different set of priorities. But
Christian,
we can't.
Christian, you had a couple of people join the queue. Can I ask you to pause for a second? For the people who join the
Yeah,
queue, please
sure.
indicate if they're clarifying questions or discussion.
I'd let questions finish because mine is not a clarifying.
Okay, so we'll assume that those are early discussion and we'll keep going. Thank you, Christian.
Okay, so what I say is you can project from 2D to 1D by making choices. The choices are explicit. They have to be made by the source. They cannot be made on the fly in the middle of the network. Next slide, please.
It was on that slide.
As I said, the card, that's good.
I think Mo wanted to jump in with this clarifying question on this slide.
Okay.
Mo Zanatti, I just thank you, Christian. It's a lot of good detail, but I got a bad feeling that everybody doesn't really get what's going on here. We had a long meeting yesterday, and I still don't feel like a lot of smart people in the room, and still don't feel like we really had breakthrough or people really understood what was going on. Trying to clarify what this really means, even if you're not choosing between two different things that receivers want, even if you're not choosing between a receiver that wants sharpness or smoothness, even just basic delivery with no receiver choice whatsoever, there is a conflict if the only level of priority that you have is something like send order, which has been proposed before. The send order is naturally the decode order of the packets as they come out of the encoder. So the encoder is streaming out the packets in the decode order that the receiver needs to decode them in. That's the natural send order that you need to prioritize, things into. But the problem becomes if you're under congestion, that order is not really encoding the priority, because if under congestion, I may want to drop some packets of a certain frame that are lower priority than other packets. I want to keep the base layer of that frame. So keep some of the packets of a single frame, and I don't want to prioritize the next frame. And I don't want to prioritize everything in the order that it was emitted by the encoder. So under congestion, there's a need for changing the way that you prioritize things, not in the order that the encoder emitted them. And that's the key thing that is not captured by something like send order.
Okay,
Okay.
Can we go to
We'll
the
ahead and
next
drain-
slide? Because I was going to give a very concrete example of exactly that issue. Unless you want to have a discussion now, of course.
No, but we would like to ask Jonathan, Bernard, and Spencer whether they have clarifying questions or not. If you can put that in the chat, we'd appreciate it. No, okay.
Okay,
Please keep going, and we'll drain the queue at the end.
so let's go to the next slide. So, as I explained, the result of the projection from 2D to 1D is to have basically an ordering in the group that says that frame A shall be sent before frame B if the priority of A is lower than the priority of B, or if they are the same priority, but the object number of A is lower than the object number of B. And after a group boundary, we can reconsider the priority, and that's a different issue, but we can discuss that later. Even to do this basic thing, we have two mappings that are considered that could make those things. There's one mapping to have one stream per group and priority level. And if you do that, you get something very nice, is that all the congestion can be handled down the stack. That is, the quick stack will naturally send the streams in order of priorities. If you have several tracks in parallel, it will do round robin within a priority order, which is a very nice way to manage the bandwidth between the tracks. And basically the right thing will happen. The other plausible mapping is to have one stream per object, but at that point, we run into the issue that is expressed in the send order. The dependency within a layer are to the previous packets. So you cannot replay a packet within a given layer without having seen the packets before it. That means that the default assumption that you should always send the last stream first, or the last packet first, or the last stream first, is wrong. I mean, that's an assumption we see, for example, in the proposed W3C API for web transport. That will do the exact opposite of what we want. Now, of course, an API is an API, so we can always play game with the API. At the end of the day, we have 64-bit numbers. We can encode the arrival with the reverse order or tweaks, etc. But you have to do tweaks in the send order in order to do that. If you do priorities, it's kind of simpler. Say, well, I have priorities, and within a given priority, I'll do FIFO. And that works. That works within a single track. That works less well within multiple tracks because the FIFO is defined by something fuzzy, like the order in which the stream has been created. And there is no guarantee that the multiple stream will be coordinated there. Overall, I think that we could make either of those strategies work. They will all require secondary work, like the group boundaries or the FIFO order of objects within a given layer. I kind of like the idea of going to one stream per group and per priority level, because it's a very natural mapping for quick, and it solves most of our issues. But, I mean, of course, we can have a debate. And Suhas, I'll give you the token back.
Thanks, Christian.
Oh, hold on. I lost my connection to the Meet Echo, so I can't control the slides. Oh, well, we can take some questions in the queue while I figure out how to get back in. Jonathan Lennox?
I think your model of collapsing everything to a single priority order doesn't handle some encoding structures, notably KSVC, which is apparently, you'll find it in the AV1 spec, and Google, this is what Google actually uses by default if you try to do multi-layer VP9 in Chrome WebRTC. Basically because, if you're familiar with that, the idea is that you've got spatial dependencies for the keyframes, but not for the p-frame, not for the non-key, not for the p-frames. So basically, you only need to send the p-frames of the layer you're actually interested in, and you can just completely omit the other ones. So I don't think your model of the priorities can handle that, unless you're doing complicated things with.
That's a very good point, Jonathan.
Yeah,
that's a very good point, Jonathan, and we should have that. It's plausible to encode that too with the layout model. To capture that, we would have the idea of marking keyframes within a layer, which is good, but could absolutely be done. And marking effectively, if you are at layer 4, which of the layer 3 frames you depend from, or whether you depend from the other layer for frames,
Yeah.
etc.
Yeah.
Yes, I mean, that's what I think is the second order of work that we have to do. I think that we have to first get a global ID that works, and then we can do the refinement that you described, which are, yes, absolutely necessary at some point.
Yeah. I mean, all right.
Bernard.
Yeah, I think you're missing something pretty important, which is how you sync up. It's not going down that's the hard thing. It's going back up, particularly in spatial, because the only ways to go back up are either you make a request back to the encoder. That would be the equivalent of Jonathan's LRR RFC, which requires tells the encoder that I want a keyframe essentially, and then you the key and key shift modes, you can kind of shift it out. But what you'll do is you'll cause a spike in all the layers to all participants, which is a problem. Or you have a periodic keyframe. So, and that gives you a point at which you know you can go up again. So that's the tricky part. And if you have a periodic keyframe, you don't have to worry so much about the dependencies because you know at that keyframe you can go back up again.
Bernard, that was pretty much thank you for pointing it out. That's kind of a hidden hypothesis. The hidden hypothesis is that there's a recurring structure of keyframes or groups or whatever, which is basically why we have the group concept there. And the beginning of a group is the point at which you go up. And yes, there are in some cases the fact that the groups are too far apart. And if they are too far apart, you want to have a signal propagating to the source saying, hey, please start the group as soon as you can because I'm looking bad right now.
Yeah, are you trying to rule out that message back to the encoder for scalability reasons?
No, I'm not ruling it out. I mean, basically, as I said, that's similar response I made to Jonathan. And in fact, Jonathan is pointing a solution to your problem with this business of intermediate keyframes at the lower layers. But what I'm thinking is that in order to make progress with the group, we have to have a global structure. There's something that are important. What I like about the priority structure is that we can push down the hard decisions down in the stack at the point of packet queuing, rather than making them in the application with some fancy structure. And I think that that's fairly important. Once we have that property, we can express that as a series of layers at different priorities, and that works well. We have then a series of secondary decisions, like how do we go up? When exactly do we have a start of a group? Do we have dependencies always to the beginning of the group, or can we have a dependency only to the previous layer, etc., etc.? Yes, those are, in my mind, things that we will come out with in the next months, probably. But we have first to get some kind of a basic idea.
Okay, thanks. We'll move on to the factors who else now.
Sure. This slide talks about what are objects in MOQ, and there's been quite a bit of discussion. It's basically a summary of what we have talked. Few of us met a couple of days back and trying to kind of summarize some of those things as well. So the idea behind what objects in MOQ include the timed media, and it can be any of this. It can be a media frame, a slice, some tile in a volumetric media environment like AR, VR, or it could be group of pictures in a HLS kind of scenarios, or it can be deadline await block, game state, and more. This basically what we're trying to say is that an application has a choice to define what that is, and we cannot really enforce what the exact boundaries of that at the transport layer. And important thing, some properties of the objects are like objects they should have unique name, and all objects can be identified given a MOQ. I'm using the word MOQ session, just not as a new terminology to say top level container, but it can be broadcast or emission, or what we call it as. And then it has a track and a group. So object belong to that. And hence, starting from one identifier, you can finally go to the actual object. And then relays cache individual objects. What are their size? They cache objects individually. And it would be required to serve some subscribe requests to get a particular object. This would be useful in the VR scenarios. It's also useful in catch-up kind of scenarios. And one of the important things about how should relays treat the object, they should pipeline. When we say pipeline, as means like relays need not have to wait for the full object to come, because sometimes if an object is a GOP, you don't know how many bytes our object are. In a frame, you might know, but objects between the relays, they are just pipelined through the relays. And we need to think about the cases where some applications, especially most of the interactive real-time kind of application, they would encrypt the object with some ciphers like AAD cipher. In that case, it becomes important that objects have delivered, if possible, with the authentication tag in them. And there's some use cases that has been brought that we need to support byte ranges. Yeah, for sure. It should be done as some parameter or a thing in subscribe that you ask for. Give me the object at a particular byte range. It's more like a get more than and subscribe, but yeah, we can definitely support if something like that is needed. Next slide, please. This kind of covers the MOQ scenarios. Should we go to the MOQ transport as well?
Okay, does anybody have any questions about scenarios draft or this presentation as it relates to scenarios? We can take those now. And then the next presentation is a little bit of a block on the new draft that was published called MOQ-T.
Ali Began, Uzzian University. I like the scenario draft, but I think it's still missing a number of critical scenarios, which are, on-demand streaming and regular live streaming, not really interactive media streaming. A lot of discussion has been around these layered codecs and things like that. But if you look at the majority of the traffic, I mean, they don't really care anything about at all those layered codec stuff. So maybe the scenario draft should actually expand to cover those issues and scenarios as well. Where maybe client-side type of adaptation to network capabilities and bandwidths and that sort of thing are also more emphasized.
Thank you.
A friendly reminder in the chat from our AD to get in the queue before speaking. But thanks, Ali. Everyone get in the queue right now. I'm just kidding. Don't do that.
Cullen, you got in the queue and then got back out. The complete opposite of what our.
I totally agree. This was just to cover the scenarios that hadn't been sort of covered in something else. I don't know what the long-term. I mean, this was a document written in my mind to help facilitate a conversation we were having a hard time getting our heads around of, and maybe it just gets thrown away. It certainly doesn't cover all the scenarios. I didn't intend it to go forward. Maybe it gets merged. Some of them get merged into Spencers or whatever, but I 100% agree. It doesn't cover, it covers a small fraction of scenarios and only the ones that we weren't already having well covered in the working group.
Yeah. So Victor is actually next, Ali,
Okay. Yeah.
since he got in queue.
Well, can I just respond quickly? Ali Began again. Yes, that's fine, but I think a scenarios, a fully scoped scenario, well-scoped scenarios document is going to help all the people in this working group. I think a lot of people are still struggling what kind of scenarios we are trying to tackle with.
So as a chair response, I'll tell you that we've been talking to the use case and requirements authors about whether the scenarios and use cases and requirements might come together. And I see Spencer is coming to stand behind Victor to address that very issue.
I can do that. I was Victor. I was actually going to comment on like a specific thing about object requirements, where we should be able to get individual objects. We should also be able to support scenarios where that just doesn't make sense. For instance, consider I'm like doing a remote desktop app and I'm just pushing my latest screen state and I don't remember whatever was before. So objects are kind of, in some cases, can be really ephemeral. And we should also keep that in mind.
I've left the queue after Spencer. Spencer? Spencer Dawkins. I'm glad that Cullen is sitting down for what I'm about to say. I think that the work that you, Suhas, Christian, Cullen have done is very helpful to moving forward in MOQ. I don't think it's perfect. That's the part that wanted to make sure Cullen was sitting down for. But I'd ask people to remember that what's being put forward, regardless of what draft it's in, is something that the working group might work on and improve. So that, number one. The other thing, I said this in chat, but just to say it here, is that y'all are using slightly different terms, some slightly different terms than many people have been using in the past. I think that those terms may be an improvement, but I would caution to people to, actually make sure that they are what you think they are before we have a long conversation about this. But thank you all three of you for doing the work.
And thanks, Spencer, for the encouraging inputs.
We are running a little bit behind, so we would ask you to.
Okay, just jumping mock transport. This would be more of highlights and summary rather than going into each and every specific things. So the main goal with mock transport was to kind of show how can we do an unified media delivery protocol, and because we started this mock group not to solve a particular problem that's happening and an application need that's happening, which is we have this live streaming moving to a case where they want interactivity, and we have these interactive applications like a WebRTC or something where they want to move away and go towards scalability. And mock was formed to be the next disruptive, best ever technology that IETF builds, and we need to make it happen. If either left if you build on left or you build your right, then there's nothing disruptive. So that's what the mock transport was, just to say everyone in the room to kind of say, no matter what draft we adopt, what we take it, the goal is to build this unified media delivery protocol, and we need to make sure the requirements for those are met. Next slide, please. So at a high level, what the mock transport draft does is that it decouples the data model from the transport and how things are mapped onto some of the transport entities. So the most basic component of mock transport is tracks. They're not tied to connection. They are not data model. They're not tied to connection or specific transport usage, but they are tracks as a data model. What a track is a transform of uncompressed media, a specific encoding and encryption process. The bag of bytes you get after that is a track. Each track has a name, and it is an authorization scope. So if someone wants to get a track from Ted's audio, I need to have a scope authorization to receive his audio or video data. And if track has an owner, tracks don't lay by themselves. Track has owner, a mock entity like an emitter, someone's phone, someone's camera, and it's under a single provider domain. When I say provider domain, it's an application provider who's responsible for that application, and it has a single encoding and encryption configuration. And to support the use cases of multi-CDN distribution systems, we need to have track to have sufficient information that will identify it unambiguously across the distribution systems. And publish and subscribe, as I explained, happens on tracks. And we do not need relays to understand bundle. Bundle is a useful concept. They might, but we do not need to enforce as a requirement that every relay should understand bundle. Bundle is a way of putting things together as a prioritization domain that makes sense in some contexts, but it does not make sense in some of the mesh relays that we are thinking about, and we don't need to understand bundle in those concepts. That's one of the differences. Next slide, please. And some of these concepts are there in the current warp spec. We just refine, and we have some PRs on the warp spec as well already. But the idea here is that there's something called control streams or messages that are the ones that set up the tracks and the necessary authorization that goes along with that. And it also manages life cycle of tracks. Because once you subscribe for an audio track or video track, you might get those media packets depending upon how someone maps each audio frame to one or each video frame to one stream versus multiple frames to a single stream, you might get a lot of streams coming to you. And there's need a way to say if someone stops a subscription or someone stops a publish, how do I clean up all my state? So control stream and control messages are basically manage the life cycle of the tracks. And there are data streams. These are the unidirectional streams on which you actually send. And MOQ transport supports both quick streams and quick datagrams for carrying media, so that we can support all the use cases that we are thinking about. And there's a thought about catalog. Catalog is also treated as a special track, which you can go to a provider session with some ID. You can get the catalog as a track. Next slide. So I'll hand over to Christian again.
Okay, I'm back. Yes, I mean, then we showed in the scenario discussion the idea of having the streams represented by a set of groups with a set of objects at different priorities. We have to have a way to encode those priorities. The way we have done that in the prototype is to pass two concepts, the priority itself and some kind of a treatment saying, hey, if we are in a case of congestion, is it better to just keep queuing and wait until either the congestion resolves or the user gives up? Or is it better to drop it now in order, or is it possible to drop it now? So that's this droppable flag, which is useful in many scenarios. I'm not going to repeat the object per stream or the multiple object per streams, but in the case of the multiple object per stream, what we want is that there is some kind of an object header to delimitate the various objects. We can have that object header very small, especially if we can make assumption that properties of the objects are common to all the objects in the stream, in which case we have to send them just once at the beginning. Next slide, please. One thing I was concerned in the transport is make sure that we don't make necessarily assumption about how the quick stack behaves, because the reality of the market today is that different quick stacks have different capabilities. Now, maybe we are going to see convergency. We are probably going to see convergency based on the priority schemes defined for HTTP3. I don't know that we are going to see much more than that, but I'd like to be able to have basically 3 layers. One is the basic layer in which the quick stack is basically not doing any kind of prioritization, in which case the prioritization is done at the application level. That's a bit gross, but you can do it at the application level because, I mean, if you don't send anything else, what you have sent will be sent before. So you can always do that by deciding what you write in the quick stack. The next level is to have something like the HTTP3 priorities, because that will be very common. So it'd be very good if what we have can be mapped to those priorities. And as long as we don't have more than 8 layers in the model, I think that we can do that. And then I read the specs of web transport put by the W3C with the idea of having a 64-bit send order, etc. That's one way. Maybe we should support that too. I'm not convinced at all that this is the right way to do it, but we shall see that. So yeah, basically have a way to map to the quick stack is what I want.
Next slide, please. Okay, summary. Even though this draft is called MOQ transport, we wanted to call WARP 05, but we didn't want to confuse the group, so we came up with the name as a placeholder. But what we want to ask to consider based on the scenarios that we presented, add some new requirements that would support the real-time use cases, and also setting up the relay mesh and the scalability considerations for that. At the same time, think about, how do we think of tracks as independent components? The current proposal says it should be tied to a web transport session or something like that, and that would limit in its usage in saying that we cannot deal with tracks on their own. And then we want to have this authorization scoped to the tracks. And applications, if they want to choose a bundle, is totally possible, and we should support them. But that's not should be the only way to go about it. And second thing is that to make relays, the bundling is one way to think of a prioritization domain, but no one has done prioritization experimentation to know if that will work, will not work. And we, at this point in the working group, we have no experiments or data to make a choice. So we need to have flexibility to support bundle as well as not bundle as a prioritization construct. Put it out there, get some numbers, and see what works best. With Quicker, we have, or the MOQ transport, if I could call, we have a prioritization scheme which we feel it works for both the use cases. Bundle is another way, but we need to have flexibility, and we're not at the point where we can make a choice on that one. Second thing is that the base transport should not define how prioritization or the send order or the new word I'm calling here as a forwarding preference is set per object, but it just should explain how it can be used by the relays. Because each application might have different ways to set it, and we need to let it be open to experiment before we make a choice on that one. Like today, it says that every bundle is a prioritization construct, which we need to experiment a bit, and we need to have the flexibility there. And the base transport should not say how it should be set. And we talked about objects. I'll not go to repeat. And there should be, since there are use cases for web transport and native quick, we should support both. And we had a few discussions amongst the authors of both the drafts, and we think it's possible to do that. Basically, step 6 is a repeat of how the forwarding preferences should work, and how should the relays should have flexibility to make choice on should I bundle or not bundle, or how do I take the streams from incoming and should I map it to same connection out on outgoing, like have one-on-one mapping from the incoming or outgoing, or I want to say merge them or split them. That's a choice relays have to make, and they have to have some experiments, some time running with that to make a proper choice. And base transport should not, or we don't have right details to enforce one or the other at this point in time.
Okay, I think that's your last slide. Yeah.
Yeah.
Okay. We are just very close to back on time, but if somebody wants to have a discussion here about these asks, or the next presentation is from Luke, who's also can talk about some of these things. I don't see anybody in the queue, and I see Luke walking slowly this way. So thank you, Suhas, for that presentation.
Hello. So wake up. I'm here. So I wanted to go over the warp 4 changes. In hindsight, we probably should have done this first because there's a lot of context from a lot of Suhas's demand, like requests. So next slide. So high level overview. We have a concept of there's 4 layers right now in the object model. There's a concept of bundles. Within a bundle, you have multiple tracks. Within a track, you have multiple objects, and within an object, you have multiple groups, and then you have multiple objects within. It's nested, it's 4 levels, it's pretty simple. Bundles used to be called broadcast, but that was confusing, so we just made up a word, bundle, like bike shed it as much as you want. It's a track bundle. And groups are similar to GOPS. That's why they're called groups. But let me go over each of those specifically. Next slide. So what is a bundle? It's just a prioritization domain. It's effectively saying that there are these tracks. Let's say it's there's audio and video, and they're prioritized against each other. That's a single bundle. If you have multiple tracks, sure, it's just a bigger bundle. If you have, let's say, 2 different meetings that are just completely unrelated, they're separate bundles. So when they're sent over a relay or over a quick connection, they are not interleaved. They are prioritized separately. So a bundle is just a prioritization domain, and it requires a connection the same connection in order to do prioritize over quick. But that's all it is. It says that these tracks are bound together. Next slide. What is a track? Hey, this is pretty simple. This is an encoded bit stream using track terminology from MP4. In this case, this is an example of a bundle with 4 different tracks. You could have audio, video, captions, time metadata. Arbitrary metadata as well, like arbitrary data. Doesn't really matter. Next slide. And then a group. We realized that the relay does need some dependency information. The previous draft had objects, which you can think of as frames, is like one analogy of thinking about it. But if the relay doesn't know how frames are related to each other, it can't really deliver them in dependency order to an extent. This is mostly a problem when somebody new joins a stream, and the relay, if it serves the most recent frame, it could be a P frame. It's just not decodable. So group is just a very basic dependency structure saying that within a group, objects can depend on each other. They cannot depend on other groups. And this is mostly for the relay for join points. Next slide. And an object. We're just calling this, I call it a fragment. In fact, I like the name fragment better, but let's not bike shed that. To the relay, this is an opaque payload. It doesn't know what's inside. It could be a frame. It could be 2 frames. It could be 3 frames. It could be audio samples. It could be a catalog. It could be an entire GOP. And this is the level at which prioritization occurs. So you have all these different fragments being sent over the network, and you set up rules to say that this object is delivered before this other object under congestion. We've got a queue.
Yeah,
The queue says that you're Miria. which is
yes, I'm
very
here.
confusing.
I can't get to the site, so.
Okay. Well, we appreciate your collegial behavior, and thank you for your, go ahead.
Yes, I'm Magnus Westland. So you have tracks, and that you say is encoding. How does that relate to media sources? So.
What's the question? Sorry.
So I think you had the bundle, and then you have the tracks, and you say tracks are in encoding. What is then a media source? Because as a bundle is.
Oh, I see what you're saying.
Yeah.
Yeah, a bundle is not necessarily scoped to a single source, as in you could have multiple tracks from different producers and put them over the same bundle.
Okay.
Basically, the tracks have to be aware of each other because they're prioritized against each other. You don't want to take some arbitrary track that says highest priority and someone that says lowest priority, put them together, and then starve. So they have to be aware of each other, but they don't need to be from the same source necessarily.
Okay, so you're gonna have to build something additional on top of tracks potentially to understand how, for example, media source to try at different encodings. If you, for example, is intending to do simulcast or something like that.
Yeah. So the relay doesn't need to know is the assumption here. The proposal is that media stuff is punted to a catalog. And the catalog describes the properties of the tracks, and I probably should have had a slide on catalog, so that the viewer knows the properties, which one to request, can I support this codec, and so it can decide what to subscribe to. And I think Mo is next.
Mo Zanetti, I think maybe what Magnus was thinking about is whether or not things can be synchronized, and whether having sources identifying themselves, identifying all their tracks to synchronize them, is that somewhere? And to clarify what Luke was saying, the object model is mostly something to make sure that the relays understand very simple basics, but the media endpoints themselves will have much more complicated models, not this 4-level object model, but there'd be a lot more detail in metadata about each object to know, and how to parse a catalog, and how to understand, media formats inside of that catalog, and how to find out what tracks are synchronized with each other. Just because they have timestamps, it doesn't mean those timestamps actually relate.
Yeah.
So you have to get that information from somewhere else, but that's opaque to the relays.
Yeah. To clarify, this is a transport level. We want to, this could work for anything. Media is just one of them, one of the use cases.
Jordy.
Sorry, I was about to ask about the synchronization between tracks, and I think it was answered. So,
yeah. And I'd like the catalog to say how to synchronize different tracks. Like, should you use PTS? Should you use wall clock time? Should you have an offset? Relay doesn't care.
Christian?
Turn the mic on. Okay. Look, it's about the bundle issue. You are saying 2 things when you say bundle. One is that a bundle is a prioritization domain, which is effectively a guarantee that if two tracks belong to the same bundle, they have compatible prioritization and can be played together. And that's a very nice property. And there is another issue is that the bundle is some kind of application concept that I will require a bundle. And I would like that we be very clear whether it's one or the other. For example, in my mind, I can see the user or the agent based on the catalog selecting a bunch of tracks, asking them for the relay, and the relay then observes that there is a property of the track that is in prioritization domain this or that, and thus that they are compatible and that can be bundled together on a single connection. Rather than say, oh, I request a bundle. Because, I mean, I think that's one of the difference with the real-time communication scenarios is that the concept of bundle is much more fuzzy. It's not something that is arranged in advance. People will look at various videos from various points in various sources in a conference. Those will be constrained to use compatible prioritization because they are part of the same conference, they're under the same authority. And they can be bundled together, and different ones can be bundled together at different points in the network. But that's not quite, I mean, we have to be clear there.
Yeah, so I want to be clear, that's why you can have multiple sources in a bundle. It's perfectly valid to combine bundles if the relay or the muxer is aware that they are doing the same scheme. So that is, they do not need to be separate, they can be split, they can be merged. It's just saying these tracks should be delivered over the same connection because they're aware of each other and they're prioritized against each other.
Yeah.
What slide do you want to be on?
Next slide. I think we already did this one, right?
Mhm.
Yeah, next again.
And then next to the object. And then...
Yeah, and technically I covered this too. We just want to make it opaque. We don't want the relay to even know this is media. It's metadata. It should never parse it. It could be encrypted. So object, it can be of any size and any content. Next slide. So some more specific properties. That was a very high level overview. These are the types of things we're hashing out that cause some of the disagreements. Let's cover them. Next slide. So bundle. In the current draft, bundle is synonymous with a web transport session, as in it is effectively a single, it's a single session. It has a URL. In this case, that's how you identify its uniqueness. And it defines that prioritization domain. Like within web transport, you have a send order. That send order only applies to that session is the current idea. But these are really the two properties it needs. It needs some way that I think the slides actually had addressability. I changed the word from uniqueness, but and yeah, so send order within a bundle, and then it's unspecified between bundles, just like web transport. I would recommend round robining, but technically you can do whatever you want. You could have a premium customer and say this bundle is more important than this bundle. Next slide. So track. Track is similarly, it's got some identifier. It's on a per bundle basis, as in tracks are bound to a bundle. They can't leave. They're a member of one. It's subscribable. And yeah, I think these are the old slides because I see my typo. So you can subscribe to tracks. These are the most common switching points. You're watching at 480p and you want to switch to 720p or whatnot. So it's one of the things you mentioned in the subscribe message. And any media properties for a track are defined in the catalog. The catalog is passed out of band. We want to make sure that only the things that the relay needs are actually on the transport.
Can I jump in to ask a clarifying question about what you mean by uniqueness? Do you mean that the same? Can you explain more about what you mean by uniqueness?
I meant addressability is what I thought I renamed this slide to. As in track has an ID and it's scoped to the bundle. Right now it's a varint, could be a string, but it is tracks are scoped to the bundle.
Okay, so you're saying there are two tracks in a bundle cannot have the same ID is the property
Yeah,
you're saying?
basically, yep.
Okay.
So that way you can subscribe to them. You give a bundle ID and a track ID as your subscribe message.
Okay.
Maybe a group ID. We'll get there, but next slide. Yeah, so a group, same thing. It's addressable on a per track basis. These are all nested, this hierarchy. So if there's a group ID, it increments. It's actually sequenced. That way the relay knows which one's newer. So if it has to choose like somebody new joined the stream, what do I serve them? I'll serve the one with a bigger number. And it's independent. So the relay can use this property to know that it just serves all the objects within a group for this new viewer, and it doesn't need to serve part of the previous one. It knows that the dependencies are bound within a group. And this is what's currently listed as a discuss in the WARPO4 draft. I think we've kind of come to a consensus on this, but we should talk about it if not. Next slide. And then object, there's more. So again, it's addressable per group. They just have an ID. Again, this is all very nested. Sequenced, you need to know which one's newer in some cases. Again, like if I'm a relay and somebody joins, I want to try to serve them the newest one first. And also to, I think, Suhas's request, if you're doing like some equivalent of range request, you want to have some way of knowing that it's from this point going forward. Again, they're prioritized based on the send order within the bundle. And this is one thing that we added in WARPO4 is incremental, as in the relay must not buffer, or must not buffer. I think I changed the wording a little bit on the new slides. The relay should stream objects. It shouldn't keep them, because otherwise every hop will add latency if it sits there to aggregate everything before forwarding it. We might add some way of making it atomic, but I don't know if that's necessary. I'd much rather relays assume it's always incremental. And then the payload is opaque to the relay. It should never look at it, should never parse it. You can think of these first four things being in the header, and then a payload just follows afterwards. Next slide. For Colin.
I just want to make the comment here that I think that most of the authors of all these drafts are in total agreement with like that we've come together on that over the last few days. We're all saying the same things about the streaming, the autonomy, atomic, and those are the same things we saw in the previous slides. So, I mean, the discuss there has had quite a lot of discussion, and I think we've come to a common viewpoint of what we should all do, and like to check with the working group that seems like what was there right now. It looks like a reasonable plan.
And again, we'll see if these slides are updated. They're not going to be. So let's go. Next slide. So the first thing we agreed on a little bit for so this is the plan for WARPO 5. We're thinking we should support raw quick. It's a request for the quick R folks. We want it to still look like web transport. We don't want to have if else's in our code base. Like if they're doing this native quick thing, we should do this, and otherwise if you use web transport, we should do something completely different. So the current plan that Victor is going to work on, and he's already started on a PR, is you include the bundle URL in a setup message, equivalent to the web transport connect. We could do pooling. I think it's pain and agony, and I would much rather find a better way of doing pooling or delegate to web transport. But it's something as a working group we should discuss. Also, if we even need a raw quick implementation of web transport is sufficient.
Okay, so we're going to take a brief pause because we didn't know I didn't realize you had updated them. So I'm going to stop sharing and try the new one.
Sure.
And we'll see if we can get back to where, we'll see whether this does turn out to be the new one.
It's minor differences, mostly in this section.
Well, seems like it would be important to get that.
Ian Sweat, while you have a moment. Yeah, you shouldn't do pooling over raw quick. It's not going to make your life better. So when you're doing web transport, since web transport allows you to have multiple sessions and all that stuff, then that gives you pooling if you really want it. In terms of whether or not you really need quick as well as web transport, I'm inclined to think of this model, we should design it so we can have both, but I do wonder if it's going to turn out that no one will ever ship that. So.
And to be clear, in production, I actually ship both because our Android team did not want to do web transport. So we use quick transport for them. So it is possible.
So Cisco, The polling has come here because we wanted to map multiple web transports onto Quick connection, and we don't have to bring that for native Quick. And if go back to our slides that Christian was presenting, we can do that without even having to do without pooling as well. So I mean, this is basically the point that we haven't decided, we haven't designed, spent much time in think about it before we decide.
Yeah, I just want to reply to Ian that I think for some of the people, for some of our use cases and things where we want to do on the embedded devices, we very much want to be able to sit on top of RawQuick, not on top of web transport. But I agree, inside of browsers, it'll be largely web transport.
I think there's a world for that, but I'd like to see a better pooling solution for Quick. Something in the Quick working group to make pooling easier. Yeah.
I think Lucas is next. Oh, there we go.
I didn't realize we were getting into the raw versus web transport discussion, so I'll try and keep it brief. Like, I asked on the list for good reasons why it's hard to do HB3, and I didn't really get anything. I don't need that now, but I'd love to know what people think that is. So, Khaled, if I could catch you at the break or something, because maybe I'm just completely misinformed. My main worry is not that you can do it; it's just that you just bifurcate the ecosystem into now, like, how the heck do I discover this versus web transport? Is it mock:// thing? If I got a web page, do I need to now have like 2 URLs for every video streaming set? Like, it's just going to compound these problems. Maybe that's solvable, but I really worry that you're just going to, like, we have this common protocol and design and two completely different worlds that never intersect, or we're going to have to create proxies that can transfer and transform between the two. And that's just like increase the whole complexity of everything for little gain.
I will remind you that you got up saying you were going to make that very short. So we will take this, but let's take it after the.
Yep, sure. Sorry.
Victor, did you have something that was clarifying or on this particular?
I just follow up to that quickly. From my experience from working group like TLS, when people start comments with like within embedded context, they're always trying to simplify things and then finds that things are complex for a reason. So we should talk more about why specifically.
So I think that we should not spend too much time in this meeting right now talking about web transport versus RawQuick, because I think there's other things and we can come back to it. It sounds like it's find each other after the meeting to discuss that.
This is probably the most contentious slide.
So we'll, and I saw, because I saw Bernard and Suhas jump in the queue. If it's, okay, there you go. Boom. Thank you.
All right, next slide. Next thing that Will's going to work on is we're going to take catalog message, and the relay doesn't need to know about it, so why does it have a message about it? And we're going to send it over a track. So you're going to have effectively a catalog track. It's going to have a different encoding. We're going to have a separate draft. Effectively, you're going to have a transport draft that the relay implements, and it just works for opaque payloads. And then a media-specific draft that the encoder and decoder is aware of that includes like what the tracks are and how they're related. We're going to have a registry for the different catalog formats, and I think the plan, at least, we would like to explore doing our own one, but also existing standards. You know, throw HLS in there if you really want. I don't. It should work in theory. Next slide. Next slide. There was one more, but it's fine. This is the only other thing I think I had in the slides was just the editorial explaining object and group that we already agree on. The current draft does not have a lot of what I presented today, so that's the next version. All right, that's it. I guess if you want to open that,
yeah,
that
okay.
Band-Aid off again.
All right, so yeah, I think we've got about 5 minutes to discuss pretty much everything we've had up until now, and then we have 10 minutes at the end for a different kind of presentation. So if anyone wants to weigh in on bundles and objects and groups.
What all I was going to say is I think one of the most useful things that people have comments on here is come talk about bundles and priorities. That's one of the things that's really challenging. You know, some of that stuff. You've got comments on that. Get them to the mic.
Will?
Hi, Will Law. Thanks, Luca. That's a great summary of months of discussion here. So it's really nice to see everything coming together, and also Suhas's work. The convergence is real, even if many people may not appreciate it. Mike, I should have written down my question. I'm dispensing accolades. The question is about, we're very quick to say pooling's complex. And so my immediate solution is I can do web transport over a quick session per my bundle. Now that works as long as I have 100 or 200 bundles. I'm spawning quick sessions, which are expensive. But if I'm a third-party relay provider, and I'm covering several 100,000 conference sessions, each of which wants a web transport and which can only do prioritization within a dedicated quick connection, I have to maintain hundreds of thousands of quick connections between every relay pair. And that, I think, is prohibitively expensive. So we need to work towards, I agree that prioritization and pooling is the key blocker challenge right now for MOQ. And I don't have an immediate solution myself, other than that's something we have to solve for scale.
Yeah, I would just say that the web transport group also thought that pooling was going to be very easy. And it's just kind of this never-ending chain of like, what about flow control? What about prioritization? What about this and this and this? So I think it is harder than it looks.
Victor?
Yeah, so I wanted to talk about kind of the other function of bundles that we kind of tried to decouple, but maybe not really, is that bundles are like associated one-to-one with like the transport endpoint, which could be like either web transport URL or like a raw quick endpoint. And like, I'm trying to think, even if we attempted to get rid of bundles and like decide the track is like our like highest level transport unit, and we do everything scope to tracks, we would still have to deal with the fact that like, in order to get multiple tracks, you probably need to connect to like some endpoint. So you still have some notion of the highest level, like the first, if you imagine the name as a tuple, the first entry in the tuple will always be like the transport endpoint to which you're connecting. Because otherwise that doesn't really work. So we might want to decouple that, but we also need to think about like, even if we don't use them as prioritization domain and prioritize within tracks, where does that URL go and what does it mean?
Like, I don't want to reiterate my slides, but the idea here is that the bundle is because it's bound to a web transport, and if you want to make it's an identifier domain construct, it makes sense. And even when we support like the web conferences, you get a catalog for the conference, and everything inside that is part of the connection I'll connect to. So that's the bundle in a way, and that has a prioritization domain. Definitely we can consider that. But as a person who's implementing some of the relay code, I would like to have to experiment on some of these things and see. I'm implementing the quick stack. I get n streams. I want to send out n streams and the objects belonging to that one. I want to make a decision, and at that point in time, should I go and round robin in a bundle? It might be one prioritization scheme, or I might, like what we have implemented in Quicker, Christian was talking about, each object carries the priority, a strict priority, and that works too. And at this point in time, tying a prioritization domain to a transport usage is too early, and we need to consider before making decisions on that.
Christian?
Yeah, I mean, it's pretty much what Suhas was saying, is that the prioritization domain is a property of the track. So we have to think of that as a track as a property, which is the prioritization domain or the prioritization algorithm that it uses. And that prioritization algorithm determines whether it can be bundled with something else or not. But that's not quite the same thing as saying a connection is a bundle, etc. I mean, I think that we are mixing things there. And I think that In particular, having the name of the track depend on the name of the bundle is not something that I'm ready to swallow, because you can just as well say that the name of the track shall depend on the source, because you want to do your routing of your connection towards the closest source. So it's really a mess. I don't think we have consensus there.
Okay, we've closed the queue. Thank you, Luke, and I think thank you to all of the authors who've worked so hard. I do think it's been a little bit of a challenge today. There's been a lot of work in the hallways at the IETF this time. That's always useful, and there's been a lot of convergence, as I think people have said. But I think it's a little bit hard for the working group to necessarily follow, because some of the context was in those. So please do use the mailing list. If there are issues that you think were raised today and you don't understand how a particular proposal came forward, please do ask on the mailing list. There's probably at least 3 other people are holding back asking the same question. And we'd like to make sure everybody comes along with the context as well as we can. In the meantime, the next person up is Tran Ma, who's going to talk about a particular set of metadata. We were actually originally planning to do this tomorrow, but because his flight schedule interfered with it, we're going to do it today. Thank you for coming, Tran. Let me get your slides.
Oh, thanks. It's a really high microphone.
Let's see. Which one is this?
It's like what?
I don't see it.
I don't see it either.
Do we have your slides?
They came late, so I wonder if Meet Echo needs to copy them over.
Let me
Oh, that's too
dismiss
bad.
this and start, see if I can get them. Yeah.
Yeah, and may I have a 10 minutes countdown?
Oh, yeah.
Sure, thank you. I'm sorry for the late submission of the PowerPoint because
No, go
the
to the
slides are
manage. Go here.
because this is
Oh,
my first time to go to the IETF meeting, come to the IETF meeting. So I just don't know where I can upload the slides until the last minute.
Import the deck. Yeah.
Well, thanks.
Now you can share it, but not from the screen. Go back to the other one.
Handy.
Here,
How do I get out of the
scroll,
screen?
scroll up out here.
Ah.
Gracious, maybe I can do that.
Now I think I need 8 minutes.
Yeah.
Minutes countdown.
I got you.
All
Assuming
right.
I don't lose Wi-Fi again.
Oh, that
I
must be
can't get
great.
out of this.
All right, just let me begin now. Oh, right. Yes. Okay, good afternoon, everyone. I'm Tran Ma from Tsinghua University. And I like to share an idea about a kind of deadline-aware extension for the media quick release. And now I thank the Yong Cui, Yixin Liao, and Hang Shi for their support of our draft. Next slide, please. And now, first of all, I'd like to make a consensus about what kind of basic agreement of us about the middleware quick release. And we list a little of them on the slide. First of all, it should get access to the header of an object, but not the encrypted content of it. It should forward package, which is obvious. It can schedule or reorder the send order of some packets it received, and it may drop some of the packets under some certain circumstances, and maybe it should implement other features or something else. But the basic agreement is that we should have some release which can schedule and it can drop the package. Next slide, please. So there are a lot of drafts in middleware quick working group that it talks about the priorities. So about the send order, the priorities, and they think that like, yes, we have the priorities so we can make it better to better scheduling. So we are considering whether this is enough for the middleware quick, especially for the real-time transport. So we think that there are at least 2 dimensions to schedule, or there are 2 different kinds of priorities. The first one is about the time, that maybe a later package is more important than the older packets, and the importance, which means the key frames is more important than the predicate frames and something like that. So that we have two different dimensions about the priority, and we have to encode them into a single priority field, which seems not a good idea. And about the global priority is also a difficult task to discuss in the mailing list, is whether we should add a global priority to show which is more important than others. And what is exactly important is that the relay don't actually know when to give up a kind of overdue object which is put forward on the mailing list, and some kind of opinions occurs then. So we think that we need some kind of indicators of the timelessness. Next slide, please. About the timelessness, I mean that we need to indicate the application's requirement and intentions about when should the data should be used and when this data should be overdue. And some kind of opinions are called, like, we call that deadline or the time to live or the max acceptable delay. Such ideas indicate that we need some kind of timeliness parameters so that the relays can be aware of the intention of the applications and they can make better decisions and to like allocate the data buffer and some other kind of resources. Next slide, please. Yes, and our draft thinks that we can add a kind of timeliness parameter called the deadline into the object's header. And here is a simple example to add it in the middle of a quick transport draft, which you can see that we can add an optional parameter field at the last of the header, and we can add some different meanings of the flags so that we can indicate the relays about how we can use these objects. Next slide, please. And for deadline-aware media transport, media quick relay components, we have three different components. The first of all is the data units. We call that a block, but actually it is an object in the media quick station. And the metadata we just mentioned that is called the deadline, is a kind of timeliness parameter. And we have some different actions for the relays. And now and next we'd like to talk about some specific movement, the actions about the relays. And next slide. First of all, it's about the ingestion. We think that the publishers can emit the object with a timestamp on it, and we call that with a Unix timestamp on the in the header, so that we can inform the relays about the latest time it should transport the kind of data. Maybe we are watching some soccer games and it is a live streaming, so it can endure like 1,000 milliseconds latency, and other like online conference we can only tolerate maybe 100 milliseconds. This timestamp meaning the expected latency for the application, and we add it to the header of the object so we can inform the relay about it. Next slide, please. Then we get the timestamp. The second one is about scheduling. The scheduling is still discussing about what kind of algorithm we should have, how we can schedule different blocks using the priority or the deadline. And we think that we can use some parameters like deadline to show that which block is more, or which object is more urgency than others, so that we can show, we can make better decisions for the relays to transport the object to the next hop. Well, next step, please. And for the drop is still an important discussion. So we think that with the deadline aware parameter, which is the deadline, and we can give up the certain blocks with that is overdue, so we can just give them up or mark them as inactive, so we can release the space of the release buffer. And some similar behaviors on the relays can also use such scheme to understand the application's intention and have a better command of what data it should transport. Next slide, please. And there are two different optional actions I'd like to add to our draft, and they are the cases we can show that how we can use such parameter of deadline. The first one is about the redundancy coding. For some specific data, we can add some redundancy code like FEC to it so that we can avoid some package losses and we can recover the data from the package. And next slide, please. The second optional function is about the drop notification and the subscriber's request. The drop notification can notice the client when the block or the object is dropped, and the client can also send the request to the release. It can claim that we can tolerate a longer delay so that we can override the deadline parameter. And this is still under discussion, and I'd like to hear your voice. And the next slide, please. And the potential benefits of the data-aware actions is, as listed on the slides, but we still need more measurement and confirmation. But the basics proposal of it is that it can lower the latency and save bandwidth and increase the real-time performance of middleware quick. Next slide, please. And the conclusion is that in the middleware quick working group, I think it is necessary to add such parameters to show the timeliness, and we should add this to the object header. And we just proposed a kind of deadline aware actions on the middleware quick release, which can to some extent to improve the real-time performance of it. And we may do our future works about to do more measurement about this idea to implement some prototypes to prove our concepts and to and then update our draft if our optional actions is further discussed. And that's all. Thank you for listening. And any question is welcome.
Okay, we have 3 people in queue and 1 person who just missed it, sorry. We will point out we're already a little bit over time. Thank you, Chuan Ma, for this. And the chairs would like to just remind folks that we wanted people to be aware of the work, but we're not anticipating that this would be taken up by this working group at this time. So it is not work proposed for adoption at this moment. It's just information for the working group about a particular approach that this research group has investigated. And for those of you who don't have incredibly great eyesight, there's a low contrast GitHub link on the bottom of the slides, so you can go to GitHub and get a little bit more detail.
I forgot to mention it.
Cullen.
Thank you. I think this idea is really good and needs to be in the draft. And we've sort of called it time to live at various times, a variant of it. And I think that we should put that in right away and have it going forward. So thank you for that. I do think, though, that on the notifications about the drops, that creates that can create a real implosion of events back. And I'm probably not in biggest favor of that. Obviously, the relays would collect as part of their metrics and operational data all the drop information and could get information at that level. But that sort of instantaneous real-time feedback, I think we'd have to think very carefully about how to do that in such a way that we didn't get an explosion of drop notifications back to the client that generated congestion. But I like the idea. Thank you.
Yes, the drop notification is especially designed for the situation when maybe there are different clients which need different kind of deadline. So we suppose that this may help, but yes, it needs further polish.
Suhas Cisco, I had a clarification question for the redundancy encoding. Do you expect to have access to the media?
Yes.
Then we need probably the release would not have the access to keys. Just letting you know if it's encrypted.
Yes, and we think that we are not going to decrypt the media data and then to add redundancy codes. We are trying to make redundancy coding with the encrypted data, and just to avoid loss of the packet.
If it requires access to the media payload, maybe we can separate 2 different layers and say there can be some kind of a deadline that normal relays, the MOQ relays can work on, and some kind of a special relays or media transformers that we're talking about that would do more special things on top of that.
Yes, we should do
Hi, I just wanted to say thank you for presenting this work. It's interesting. I think it's the kind of thing generally that it would be good and might need a solution. I think we discussed clocks in Quick. Will could probably attest to like difficulty of time synchronization in things like Dash, especially low latency and the tolerances there. Like, I think that's something that's going to be really hard to solve, but that could totally be done. So keep up the good work.
Yes, thank you for your comment.
Thank you again, Chuanma, and thank you all. Reminder that we have another session tomorrow in the last session of IETF 116. We look forward to seeing you there. And thanks again to our note takers. Come up and collect your candy. Oh, yeah, we'll post that to the list. And remember, if you had context questions on today's, please post the questions to the list. Thank you.